Today at marktroyer.tech, we will be assembling the Tasmota Learning PCB, loading the latest firmware, and configuring it for the optimal learning experience. Let's get started. This is the second episode of marktroyer.tech. Today we will continue where we left off in episode 1. We will assemble the PCB that we designed. We'll then load the latest version of Tasmota, which is version 7.1. We will configure a device template in Tasmota. We will then enter some console commands in the device to get the exact behavior that we want. And finally, we'll review 3 bonus commands. Let's go to the bench. Yesterday, I received this box from Shenzhen, China from PCBWay. These are all the PCBs that we created last week, and we are now going to assemble this PC with all of its components. Let's take a look at the bill of materials. I'm not going to run through all of the parts, only a couple of notes that I think are worthy of mentioning. To begin with, let's consider the WeMOS D1 Mini. My recommendation is to not solder the D1 Mini directly to the PCB. Instead, use header pins. This way you can then swap out D1 Minis if required. For the 4 LED lights, different colors should be used. In order that the brightness for all LEDs are the same, different values of current limiting resistors have been spec'd out. In order to move things along, we'll fast forward through the actual assembly of the PCB. The total build time took around 20 to 25 minutes. As this build uses through-hole components versus surface mount components, most beginners can take on this task. Only the most basic soldering tools are required. This may sound strange, but there's something about the assembly and soldering process that gives me complete peace. It's the focus on the precision and the technique. I know I enjoy it as I totally lose all sense of time. It's the physical world which is in contrast with the logical software world. And here we have the finished assembly. Back to the virtual world. Before we start configuring Tasmota for this new device, we're going to install the latest stable release of Tasmota. This is version 9.1 with a release name called LMO Gen. To upload the firmware, we will be using the Tasmotizer tool. With the latest release of Tasmota loaded, we will now configure the device on a local Wi-Fi network using the standard Tasmota network configuration process. In its initial factory state, Tasmota will be configured as a SON-OFF basic. On the Learning Tasmota PCB, button 2 and LEDs 2 and 3 are assigned to the SON-OFF basic GPIO pins. Now we will remap all of the GPIO pins to the devices on the PCB. In the interest of learning, we will vary the mappings of the momentary push buttons and the LEDs to different definition types. Button 1 will be mapped to the button definition, while button 2 will be matched to a switch definition. LED 1 will be mapped to a relay, while LEDs 2 and 3 will be mapped to an LED definition, and LED 4 will be mapped to a PWM or pulse width modulation definition. This diagram shows how we will do this and how it is configured in the template definition in Tasmota. For Learning Tasmota, this is an ideal configuration. Let's configure Tasmota to match this configuration. As we can see, the firmware is still configured as a SON-OFF basic. We will select the Configure Template option to start. Let's begin by naming this template Learning Tasmota PCB. We will then configure all the GPIO ports to match the previous diagram. If you have done this for releases of Tasmota prior to 7.0, you will notice that the component configuration user interface has changed. It is now more modular, although the D-pin markings found on the D1 Mini are no longer on the interface. Only the native ESP8266 GPIO pins are indicated. The configuration of the template is now complete, but still not active. To activate it, we need to go back into the Configure Module menu option and select it from the pull-down menu. We can now select the Learning Tasmota PCB option and save. The device will now reboot into the newly created template configuration. Now we are going to test the various components configured in Tasmota and perform some additional configuration steps in the interest of learning. To start, let's verify that the light sensor is working. I will wave my hand between the LDR sensing device and a light that is shining on the device. We can see updates every 2 to 3 seconds on the web user interface in the illuminance field. Now let's test the Maxim DS18B20 temperature sensor by waving my soldering iron by the device. The ambient temperature is around 22.1 Celsius and we will see it rise a degree or two. Now let's move to the buttons and LEDs. The first button was set to the Tasmota definition of button 1, while the first LED was set to the relay 1 definition. As these definitions are logically and semantically linked in Tasmota, we can see that the button directly toggles the relay, or in this case, the LED. The second momentary push button was configured to a definition of Switch 1. The default semantic behavior is for the definition to also toggle relay 1. This is odd. We would like to decouple Switch 1 from relay 1. To do this, we will enter the console found in the main menu. In the console, we can further customize behavior while also seeing real-time events occurring on the device. For example, we can see that the previous clicks of both momentary push buttons resulted in the toggling of the relay 1 state between on and off. In order to decouple all the switch definition configurations from relays, there is a command line directive called set option 114, and we can set that to on. By entering this command, all Tasmota switch definitions are now decoupled from the relays. We now only see the events in the console when switch 1 is pressed, and the state of relay 1 does not change. This prompts the question of what do all of the preceding 113 set option commands do? There does not seem to be a single page in the documentation where all of these definitions are pulled together. Instead, each option is only documented within specific functional areas. This is a to-do list for the future. Getting back on track, we can see that pressing switch 1 only resulted in log entries indicating a toggle. Let's change this behavior on switch 1 from a toggle switch to a simple button where pressing the button down results in an on state and releasing the button results in an off state. We do this with the switch mode command. In this case, switch mode 1 space 2. There are over 11 switch mode settings with minor nuances related to rising and falling edges and other behavior. 2 is used for an inverted push button mode as the button is pulled low to ground in its open state. With the command run, pushing the button now results in 2 state changes, first on, then off. We will now test some of the commands that can be used to change the state of a relay, LED, or buzzer. These are important as they build the foundation for rule automations. We will be introducing an example rule automation in the bonus section at the end of this video. To start, the power command is used to query or change the state of a relay. We will test both power 1 on and power 1 off. To control an LED, we use the LED power command. It is used to query or change the state of an LED. Let's test the LED power 2 on command and now the LED power 2 off command. The dimmer command is used for a PWM configured LED. We can set it to a percentage between 0 and 100%. Let's test it with the dimmer 50 command and then the dimmer 10 command. Finally, we can sound the beeper with the buzzer command. The buzzer command takes 4 arguments: a count, followed by a beep, followed by silence, followed by tune. As an example, buzzer 5,1 will beep 5 times with 100 millisecond steps. Let's try that. Let's summarize what we've just configured. After assembling our Learning Tasmota PCB, we loaded Tasmota version 7.1 firmware on the device. We then configured Tasmota with 10 components. For the purposes of learning, we configured the push buttons and LEDs differently. Some custom commands were made on the console for the second push button, and then we exercised the various commands to turn on the relays, LEDs, PWM LEDs, and then the buzzer. Now it's time for the bonus commands which build on all of this work. There are 3 commands we will review. The first is the template command. This command allows you to view the configuration in JSON format. In this case, all 10 device mappings are included in a return string. After doing any testing, it's a good idea to copy-paste these away for good keeping, as they can be pasted back into Tasmota if required. The second command is the reset3 command. This command removes the currently configured template configuration and resets the device to factory settings. It does this, however, without having to reconfigure the Wi-Fi settings. Finally, we'll leave you today with a rule automation. Earlier, we decoupled Switch 1 from the relay and changed its action behavior. As a result, pressing the button down will result in an on state change and event. Releasing the button will result in an off state change and event. Our rule automation will link these state changes to commands that will turn LED 2 on and off. Rule automations are a powerful part of Tasmota that give us some basic programming capability without the overhead of a full development environment. The structure of a rule is simple. It consists of a rule number followed by event actions. The syntax consists of on, do, and end on reserved words. Like an if-then statement in modern programming languages, it allows us to execute certain commands based on conditional events. In our case, we'll set up a rule to wait for a Switch 1 event that will trigger an LED power command. When entering rules in the console interface, all of the rules should be placed in a single line. There are 3 rule buffers. Each are deactivated by default and must be activated. In this case, we will simply enter Rule 1 on. Now LED 3 will turn on when Switch 1 is pressed and turn off when released. It's time to wrap up. Today we assembled and configured the Learning Tasmota PCB in an ideal state for learning and mastering Tasmota. In future episodes, we'll integrate with an MQTT broker and Node-RED. If you are new to Tasmota, I urge you to try these configurations with a Learning Tasmota PCB or even a breadboard. I've made the Learning Tasmota PCB directly available for ordering from PCBWay. The link in the episode notes includes all of the commands that we've executed today. In order to help get this channel off the ground, I would appreciate a vote on the PCBWay channel for this shared project. More videos with reference PCBs shall be coming in the future. Finally, please like this video if you found it useful or interesting. And please subscribe so that you know immediately when I come out with the next episode. Until the next time, this is Mark at marktroyer.tech signing off.